cheese processing company, kind of makes me want cheese, huh? Wants to estimate the mean cholesterol, till you read that, content of all 1 ounce serving types of cheese. The estimate must be within 0.76 milligrams of the population mean. Determine the sample size. So the sample size is n, and how you find that is you get the z-score times the standard deviation over the error squared. Okay, so not really a shortcut way to do it, you just plug the things in. Now, they give you the tables here, which is fine and dandy if you've actually watched my video on how to read a z-table. Most students really struggle with it, so what I like are these, I call them cheat tables, that typically have the percentages 95, 90, 99, the ones that they ask for. So as you can see, I would use 1.96 and then times, somewhere they give me the standard deviation, 3.15 over 0.76 squared. And I throw that in my calculator, and you always round up. No matter what the decimal is, you round up and get one more. So the sample size would be 66. Okay, now they want me to do a confidence interval, which a confidence interval around the sample mean is the sample mean minus the error and the sample mean plus the error. So you're wondering, how do you find the error? Is that 0.76? No, this is actually calculated, but you're going to see, in this case, will be the same 0.76 value. But let me just show you how it was calculated. The error is z times the standard deviation over the square root of the sample size. In our case was 1.96 times 3.15, and you found the sample size of 66, and you will get the 0.7599 or 0.76. Okay, so all I'd have to do is take the mean that they give me here, and let's go back to orange, and take 26 minus this 7.599, and I'll go ahead and round 25.24, and then 26 plus this value, again, is my error, and gives me 26.76. So that is the interval, 26.76. Now, if you have a program like StatCrunch, which is so lovely and so nice that you could actually use, you could just simply take that and go to Stat, go to Z-Stats, one sample with summary. We don't have data. We know it's a Z because they give us the population standard deviation. Put in my values, 26, my standard deviation, 3.15, my sample size that we found, 66, and do a 95% confidence interval, and you would see the 25.24 and the 26.76. So you'd get the same answer. So it's just a nice quick way if you don't want to do this, not too much manually, but manually. Okay, now this last part here, they talk about, let's get that out of the way so I can read it. They talk about, does it seem likely the population mean could be within 3% of the sample mean? Okay, so what we want to do is we want to figure out what is 3% of our sample mean, which was what, 26, meaning 0.03 times 26, and we get 0.78. So what we would do is we would do our mean minus that, once again looking at the mean minus the error, the mean plus the error, 0.78. Notice, if you had this on a number line, I wrote 25.24 in my horrible handwriting, that should be 22. If you wrote these values on an actual number line, the 25.22 would be down here, and the 26.78 would be up there, right? So basically what we're saying is that no, It does not seem likely that the population mean could be within 3% of the sample mean, because this 3% off from the sample mean would fall outside the confidence interval, which it did. You do the same thing with the, if I can find it, the 0.3, but that now is going to be 0.003 times 26, which gives me 0.078. You take the mean minus that value, and you get 25.92, and you take the mean plus that value, and you get 26.08 rounded. If you notice, these are 25.92 would be like right there. This would be inside there. So this, it does seem likely that the population mean could be within that 0.3%. So that last part's probably the more confusing part, but you're just taking 3% and then 0.3% of the mean and seeing, does it match within your interval? And that's it.